Many statistical procedures have a single fit index, for example, F-test in ANOVA. But in structural equation modelings, there are many model fit indices. Many of these indices compare the model implied covariance matrix to the sample covariance matrix. If the model implied covariance matrix and the sample covariance matrix are similar in some fashion, then one may say that the data fits the theoretical model. If the model implied covariance matrix and the sample covariance matrix are quite different, then one may say that the data does not fit the theoretical model. The most widely used indices are chi-square, comparative fit index, Tucker-Lewis index, root mean square error of approximation, standardized root mean residual. Needless to say, besides looking at the overall model fit, you also need to look at the parameter estimates. Do they have the correct sign, either positive or negative? Do they make sense? Are they statistically significant? For interpreting the model fit indices, the recommendations are as follow. Significant chi-square means that the model is not a good fit. However, given that chi-square is sensitive to sample size and in large samples will almost always be significant, other indices should be considered. Comparative fit index and Tucker-Lewis index greater or equal to 0.95 indicate good model fit. Root mean square error of approximation values less than 0.06 likewise indicate good fit, and values between 0.06 and 0.08 suggest moderate fit, while root mean square error of approximation values greater than 0.08 indicate poor fit. Which indices to choose? To avoid cherry picking the ones that support your conclusions, you should report several, such as the chi-square, the comparative fit index, the root mean square error of approximation, or the standardized root mean residual. When we will assess measurement invariance, we will look at the change in the model fit indices to see whether invariance is met or not. Significant chi-square indicates non-invariance. Also, change in the comparative fit index and Tucker-Lewis index greater than 0.01 indicate non-invariance. Change in the root mean square error of approximation greater than 0.015 also indicate non-invariance. So we should remember and write down these values because we are going to refer to them later on when we assess measurement invariance.